Yeah, good morning all. So in the last class, we were discussing about bottom preparation. So we'll continue that. Today we will be discussing about testings, various testings, whatever we're going to do for the whole, which we're going to subject for the code making process. But before that, one should know what are the various constituents of coal. So coal basically consisting of petrological constituents where we can separate it by washing techniques. So in all, most of the integrated steel plants will be having a coal washeries for this separation purpose. And apart from this, we have some elemental constraints where we can find it out through the ultimate analysis. And rest of the constraints which are very much important for its use, those can be find it out through the approximate analysis. So petrological constituents are basically distinguished under a microscope on the basis of their reflectance. So depending upon the reflectance, we can decide the rank of the coal. So again, rank of the coal is basically depends upon the maturity of the coal. That means if the carbonaceous matter is more, that means the coal is highly mature. So there are some minerals which are present that these coals. So those are grouped as vitrinite, hexenite, and inertinite. Vitrinite is basically present in igneous kind of coals, and it is existed in the form of bands, which is derived from the woody tissues of plants, and they are rich in cellulose and lignin. You can see in this particular picture where we have vitrinites, which are located in the form of bands, the blue color ones. So they are very reactive minerals that burns readily when it undergo combustion. And hexenite, these group of minerals are minor components of coal and which are very much rich in the volatile matter, and they are most reactive. Similarly, the inertinite, in the name itself, it is there, it is inert, the inert group of minerals which are non-reactive, and they will be present in the form of tiny flakes having distributed around 1 to 3% in coal. So the extrinsic mineral matter which are incorporated with the coal in the bulk form, that could be separated by washing techniques, but whereas which are present inside, those cannot be separated. And these mineral matter remains as ash after coal combustion, which is not desired for the coal. Before we subject metallurgical coals for the coke making process, we undergo some testings to check the feasibility of the coal for the coke making process. We do certain tests for the coals because when the coal is subjected to the coke making process inside the coke ovens, these coals will undergo some peculiar physical changes. All the coals will undergo some chemical changes, but only metallurgical coals, along with the chemical changes, they also undergo some physical changes. So we need to check whether the coals are having the behavior or not. So that's why to check this, we do some testings. First one is the caking property. So a good metallurgical coal should have good caking tendency. It should form a solid mass at the end of cooking process. The compacted coal, whatever we are subjecting to the coke ovens, especially in non-recovery coke ovens, they have to get agglomerated during cooking process and form solid porous mass. So to check this kind of agglomerating behavior under the lab scale, we do testings for the coal by taking a small sample of 20 grams, and we keep this 20 grams of sample in a boat which is made up of silica refractory material and heat it to a temperature of 600 degrees centigrade and then cool down to the room temperature, and we check whether the coal is getting agglomerated or not. And based upon that, we come to conclusion that this coal is having good caking tendency. We have some standard charts, and we have to compare sample with the standard chart, and based upon that, we can evaluate the property of the coal. So in this particular slide, we can see the standard chart that is ranging from A to G series. And also you can see the behavior of the coal under different series. So the non-coking coals are basically comes under A category. We can see that it is not get agglomerated. It is looking like a perfectly separate individual coke particles we have. So there is no agglomeration has happened. There is no caking tendency. This coke is not having caking tendency. Similarly, you can see in B grade and C grade, here also partially certain extent they have agglomerated. But from the D series onwards, you can see it's perfectly, coke particles are perfectly agglomerated and form a single solid mass. So this caking tendency is very much necessary during the coke making process, and this is purely depends upon the amount of the volatile matter present in the coals. Coals with high amount of volatile matter have this high caking tendency. And also, not only this, the coals, whatever we are subjecting for the coke making process, they undergo swelling. Because during the expulsion of this volatile matter in the coke making process, the coals will get swell. So we have to check the swelling tendency of the coals also. That we quantify based upon the CSN values, coal swelling number or Crucible swelling number. At a laboratory scale, again, this can also will be done. For that, we take 1 gram of coal sample having particle size of less than 72 micron size, and again, this is again kept in a silica crucible inside an oven, and it is and this crucible is getting heated from the bottom onwards to a temperature of 800 degrees centigrade with a closed lid. And after that, we can observe behavior of the coal with the standard chart. Again, we have this is a standard chart. The coals which having good swelling nature will have swelling number ranging from minimum 4. So you can see here the coals with swelling number 4 and above are considered as good coals, and those can be used for the coke making process. Similarly, the crushing tendency of the coals, whether the coal is hard or soft, because especially if you see the non-recovery coke oven process, where around 90%, minimum 85 to 90% of coal, whatever we are subjecting for the charging process, that will be of minus 3 mm size. So to make size of minus 3 mm, the coal should have grinding ability. So to check this grinding ability of the coke, we subject the coal for grinding process that is called as hard groove grindability index. So before any coal is charged for coke making process, it is crushed to at least 80% below 3 mm. Why? Because to achieve good bulk density inside the ovens. So this can be determined by considering sample of 50 grams, and you subject that for the grinding by applying a load of 284 Newton by using some grinding media, that is steel balls, and you rotate this sample inside the drum 60 revolutions, and then collect the sample, screen it using 200 mesh, and the amount of coal which is passed through that particular screen will determine the grindability index of the coal. So to find it out, the hard groove grindability index of any coal, we have this formula. is HGI is equal to 6.93 m plus 13, where m is nothing but the weight of the coal which is passed through this 75 micron sieve. So the higher this value, that means the softer is the coal. So coals which are having less than 45, those are called as hard coals, and coals with minimum of HJ 50 to 52 minimum, they are called as soft coals, and they are suitable for the coke making process. And apart from these three, we also test the fluidity of the coals, because as I said that all coals cannot be undergo some physical changes. Physical changes means they have to undergo softening, then swelling, then semi-plastic and completely plastic. So this is what actually transformation which happens inside the coke ovens when you subject the coal for the coke making process. So any coals which are undergoing this transformation, this kind of behavior, then those are called as metallurgical coals, and the coke, whatever it is prepared from these metallurgical coals, are called as metallurgical coke. So we also test the plasticity of the coals by using plastometers. So as I already discussed in the previous classes, that we have a very limited quantity of prime coking coals in India, roughly less than 3%. So to utilize this prime coking coals effectively for a long duration of time, the Central Fuel Research Institute, CFRI, has developed a coal blending technique where we can, instead of using the prime coking coals as a major raw material for coke making process, instead of that, you can blend different grades of coals and you can make the coal cake or coke making process. And the amount of these proportion of these coal, it should be present within that coal cake in an appropriate quantity. So that combination, it was actually designed by CFRI, Dhanbad. That is, we can use low VM prime coking coals around 45 to 50%, and medium VM coking coals to around 30 to 40%, and high VM semi, or you can say weekly coking coals around 10 to 20%. So if you can blend these coals in this manner, then we can stay for a longer duration of time. We can utilize these prime coking coals for longer duration. Now we will move on to the coke making process. So this is the general flow chart of coke making process. We basically bring the coal from outside the mines, and by different means of transport, mostly by the railways And then once it is reached to the plant area, so by using the various raw material handling systems, especially we use wagon tipplers to unload the coal from the railway wagons, and that unloaded coal is to the transported to the coal yards, to the conveyor belts, and from there again we subject for, if it is Indian coals, then we need to subject for the uh, washing process. If it is an imported coal, then we can directly utilize it for the making process. The only thing is the comminution, that is sizing, in which we need to do, and then blending we need to do. Okay. So these coals, whatever we have stored in the stockyard, those can be again reclaimed through stock reclaimers, and we can transport to the conveyor belts, the bunkers, and from the bunkers, the wave feeders with the proper appropriate weight, we can charge it onto the conveyor belts, and from there we need to subject for the hammer mill, that is the crushing, where we need to crush it maximum 90% to less than 3 mm. And this crushed coal, again from the hammer mill to the conveyor belt, it will go to the stamp charging system. See, this is the flow chart which I am actually discussing with respect to the non-recovery cocoa process, where our parent group uh, follows this process. And then this stamped coal is subjected to the cocoa oven, to the chakar, and then it is subjected for cooking process for a duration of around 68 to 72 hours. Once the cooking is done, then this entire coke will be pushed from the oven to the into the quench car, where the quench car is again moved to the quenching station, where the red hot coke subjected for the cooling process. There are again two different techniques are there. You can go with dry cooling and wet cooling. But here in our plant, we do the wet cooling using water as a media, and we quench it not only under the quenching covers, but also after that also we do the manual sprinkling of water, and then we used to allow it cool it down to room temperature, and then cool coke came through the conveyor belt. It will be sent to the crushing, followed by the screening, and then the screened coke is again dispatched to the various departments wherever it is necessary. It can be the blast furnace department, or it can be the sinter department. Okay. So this is the flow of the raw material, especially the coke, inside an integrated steel plant. So this is actually the hammer mill, what was discussing. So this is the feed end. You can see this is the animated part. This is how the crushing basically takes place to the hammer mill. This consisting of rotating hammers is fitted to the spindle. You can see the rotating hammers in this particular picture. And we'll be feeding from the top, and whatever the coal which we are feeding, that will be heated by the rotating hammers, and it is collected at the bottom. And you have screening system will be there at the bottom, where we have a double screening systems will be there. What undersized and oversized coal particles are getting separated. The undersized particles will be transported to conveyor belt to the stamp charging system, whereas oversized will be again will be recycled and allowed to make it feed from the top. Coal precorporation techniques. So the bulk density, the property which is very important, which decides the coke quality and the coke productivity. High bulk density of the coal charge enhances the throughput of the oven with better quality of coke. There are various techniques to improve the bulk density, and these are called as precarburation techniques. It include selective coal crushing, coal preheating, coal briquetting, and stamp charging. So these are the four precarburation techniques, but out of which I'll be discussing about the last one, that is the stamp charging process, where our the JHP plant basically follow this process. So in the stamp charging, the density of the coal is increased by physical stamping the charge into a cake outside the oven, and this cake, which is almost similar in size to the oven, that is inserted into the oven. So the coal cake, whatever it is produced from the stamp charging system by using coal particles of size less than 3 mm, and the cake, whatever it is formed, that will be having dimensions in terms of width and length will be of similar to the dimensions of the non-recoverable coke oven. And here we are applying a load of 10 tons to make a coal cake having a bulk density around 1150 kg per meter cube. So we are not using any external binders during the stamping process. Only thing is that we add little amount of moisture. Around 10% of the moisture is added, which that itself will act as a binding media. And finally, we are able to produce a coal cake of 50-ton capacity, having dimensions of 1 meter in height, 13 meter in length, and 3.4 meter in width. So these two, that is the length and the width, is almost equal to the dimensions of your oven. And this coal cake, whatever we have prepared, that is by blending of different types of coals. So properties, please focus on this particular table. Again, we will discuss this in the further classes. See, we need to focus on these properties. You see, this is the properties of your coal cake before you subject into the cocoa buns. It's having the volatile matter of 20 to 24 maximum, and moisture content around 8 to 11%, and ash content it is as received, and fixed carbon 66 to 68%. Crucible swelling number it is around 78, and bulk density 1.05 to 1.1, and mean maximum reflectance we have 1 to 1.2, and we have fluidity 500 to 700 dial division per minute. Out of this, if you focus on these three, that is, one is VM, other one is the moisture, and the third thing is the FC, fixed carbon. So once this coal is subjected for the coke making process, certainly you can see a variation on these parameters, VM, moisture, and FC. So this is the pictorial view of sequence of operations to undergo in the coke making department. You can see coal tower, and you can also see the conveyor belt here. So the blended coal which undergone the stamping process, which undergone the crushing process, that is, before this coal tower we have the hammer mill is there. Okay, so this conveyor belt is actually connected one end to the hammer mill. So from there, whatever the undersized coal, that is whatever the coal which is having less than 3 mm size, that coal will be transported through the conveyor belt to the coal tower. And in the coal tower, we have, this is what the bunker you have here at the top, and this is the stamping system we have, hydraulic stamping system we have, where we apply 10 tons of load for the stamping process. Okay, and you can see there is a small video which shows how the stamping is taking place. This is a movable hydraulic stamping machine. Whenever the charge is fallen down from the bunker, a load is applied, and also we can keenly observe certain amount of moisture. As I told you, 10% of moisture we basically add, which acts as a binder. We can see during the stamping process, a certain amount of water is sprinkled at the vicinity of the stamping area. So you can see this hydraulic stamping machine is moving on a rail track. Right. So like this, layer by layer charging of a coal and stamping takes place simultaneously, and finally you'll end up with a coal cake like this. 50 tons of coal cake which is formed through this coal stamp charging process. And whatever the coal which is prepared, that will be subjected inside the oven. We have different types of ovens are there. initially we have beef coke ovens used to be there. You can see in this first picture in the good olden days, and these are having certain disadvantages. They have some limitations where the quality of the coke, whatever it is producing from these ovens, are not uniform. So they have slowly, means this is a prototype of whatever the ovens which we have, you can say, the non-recovery coke ovens, and we have byproduct coke ovens. So today we have these two ovens are existed in different steel plants. Some of the plants are adopting non-recovery coke oven process, and some plants are adopting byproduct coke oven process for production of coke. So in the next class, we'll be discuss about the various coke making methods. Thank you.